Saxon Algebra 1, Lesson 71. We have a two-parter today. Both are algebraic treats. The first thing we want to talk about is factoring trinomials with common factors. We've talked about common factors before. They're matching bits that you can pull out. And that's exactly how they're going to work in these lovely problems. Let's see how many there are. There are 4 in this part of the lesson. And then we have another topic with just one problem, all right? Factor is what our instructions say. Sometimes that word will give us the instruction will give us a nice clue as to what we're supposed to do. And as I copy this problem down, and maybe you would be looking at it in your homework, we see, okay, it looks kind of like a trinomial, but it's not right. These exponents are messed up. They're supposed to be squared, plain x, and no x, but this is cubed, squared, and x. Now, when I first learned these, I thought, somehow I need to make that term go away. Not bad thinking, but there's an easier way to fix the whole mess if we notice that each one of these terms has one x more than we like. So what we do is we factor out the x. If we take 1x out of this, we'll have x squared. If we take 1x out of this, we'll have 6x. And if we take 1x out of this, we'll have 5. Oh, now it looks better, doesn't it? A good trick for these problems is to put them in order and then look at the biggest term and say, I want to turn that into a squared, just a plain number squared. How do I do it? And in this case, we see, oh, it's got 1x too many, so we pull out the x's. We'll use that strategy in our other problems and see if it works for us. Now, we go ahead and factor this trinomial part the way we ordinarily do, and this x is just going to behave itself sitting right here in the front position. So now, we start with the x's. We look for a number that multiplies to 5 and adds to 6. There are only 2 numbers that multiply, 2 sets of numbers that multiply to positive 5. 5 and 1, negative 5 and negative 1. We quickly see, oh, it's this one. It's fine if you start carrying this work in your head, but if you ever get stuck or think, oh, there's not a pair of numbers, write them down. It'll help you figure it out. And now I just do the art project. X plus 5, x plus 1, and this is the final answer, okay? So this common factor of the x that we pulled out, it just sits out here in the front and harms no one. 71.2. All right, 4bx cubed. Oh, look at what a mess that is. My tip for you is make sure you have this arranged in descending order, right? Biggest exponent, and then keep them in order. Once you have that, take a look at this first one and say, what do I want to get rid of to make this into just a plain x squared? And then once you figure that out, look and see if you can pull it out of all the others. So I quickly see, oh man, I want to pull a 4 and a b, and there's still too many x's. So I want to pull a 4bx out of this term because that will leave me with the x squared. If I pull it out of here, I'll have 1x left. That'll be good. And I can take the b and the x, and I can divide this by 4 evenly. So all green lights across the board, and I'm ready to now do my actual factoring. When I pull this out of here, I have the x squared left, just like I planned it. When I pull a 4bx out of here, I have minus x. And when I pull a 4bx out of here, I have minus 20, and that's all. Okay? Interesting, right? John sets these problems up for us, so they're delightful, right? And our trick will work. It's not a trick, it's a strategy. Look at the highest order term and think what you'd have to factor out to get that to be just a nice little x squared the way we want it. Then once you identify that piece, check and make sure that it will come out evenly of the other terms as well. Spoilers, John sets it up beautifully for us, so we don't have to worry about it. Be careful with your minus signs. If we're factoring out a positive, which we definitely want to do, then pay attention to your sign so that that will work out perfectly. Just like before, we'll leave that term on the outside. We won't pay any more attention to it, and we'll just factor this trinomial like we always have. 20 minus 20, the difference is -1, so I'm going to guess it's -5 times +4. And just to be careful, I'll write it the other way as well. And there's 2s and 10s, and there's 1s and 20s. I'm not even going to list those because I can see pretty quickly that this is the right answer. So x minus 5, x plus 4. I double check. These two multiply to this one, and they add to that -1, invisible 1 there. This is our beautiful answer. Notice that once you factor out that common factor, you're done. You don't have to do anything more with it. All right? 73. No, not 73. 71.3. There's a difference. All right, so this one, again, we're factoring. And again, we ask ourselves, what do we have to do to this first term to turn it into a cute little x squared the way we want? And here we see, oh, the problem is the minus sign. How do we factor out a minus sign? Well, we remember that we can draw in a 1 if we want. And so we're going to factor out. You can think of it as the minus sign being factored out, or you can think of it as a -1, whichever way makes you feel better. This, if we're taking a -1 out or a minus sign, then this, oh, just a second, let me do this one first. This becomes x squared. This, it changes the sign, so it becomes -x, and it changes the sign -20. And we can double check this. Sometimes the simple pulling out the minus sign is the most mind-boggling. We can check our work by distributing back, right? If we did it right, multiplying these out should get us back to our original term. -x squared plus x plus 20. Yay, we passed the test. Now, instead of writing the 1, it's not wrong to do that. It just isn't sophisticated from a mathematician's point of view. So, you know, you want to be cool, I know. So we're going to change it to just a minus sign, not the 1. Think of it, though, however it makes the most sense to you. Okay, so now we're looking for numbers that multiply to -20 and add to -1. Well, we just did that. So it's like so. Wait, this is +4, sorry. This, right? Yay. Good, interesting. We got the same answer, we just factored out something different. As before, we leave the common factor out here in the front of the pair of binomials that we factored it down into. Okay, one more of these and then we'll switch gears. Squeaky chair. Okay, they're in the proper order. John has not messed with our heads on that one yet. He will later. He'll mess up the order of this and we have to put it back. All of these we see are in order. There's the 3, there's the 2, there's the plain x. Invisible exponent of 1 on there, right? We could put a 1 on there if we wanted. 3, 2, 1. Oh, works perfectly. And again, we look at the biggest one and say, what do we need to get rid of to turn that into an x squared? And we see, well, it's a minus. We need to pull out a minus sign. We need to pull out a 3, and there's an extra x, so let's pull out a -3x. Now let's look and see, oh look, it's gonna work perfectly all the way down, right? These guys each have an extra x, and these are all divisible by 3. 7 plus 2 equals 9. 9 is divisible by 3, so it passes the test. Remember that weird test for dividing by 3s? You add the digits separately. 7 plus 2 equals 9. 3 goes into 9, boom, we know. All right, so let's factor this out. From here, we're gonna be left with x squared, just like we hope. This is gonna be plus 2x, right? And again, we can double check by multiplying. That will give me my minus 6 and my x squared. Perfect. And then this is going to be minus. Now, how many times does 3 go into 70? 3 times 20 is 60. I'm just going to make some little notes here. 3 times 20 equals 60. That gives me, 60. And that gives, from 72, that gives me 12 more that I need to figure out, right? 60 plus 12 is 72. That's the number I'm trying to get to. What multiplies to 12? Oh, 3 times 4 equals 12. So that tells me that 3 times 24 equals 72. So this will be 24, and the x is factored out, so that's the end. Oh, well that's nice, right? Leave the common factor alone, set up the binomials, put in the x's, look for the numbers. Now 24 is one of those numbers that has a ton of factor pairs. So let's narrow down. We see this is minus, so that means we're gonna need a plus and a minus, and we're looking for two factors. Since there'll be plus and minus, their difference is 2. Now, I automatically cancel out 12 and 2 because their difference is 10. I cancel out 8 and 3 because their difference is 5, right? 8 and 3. And that gets me really quickly to 6 times 4. See how I'm mentally playing with the numbers in my head before I start writing them down? You can start doing that as you feel comfortable. If not, just write them all down. But I'm suspecting that it's 6 and 4. So let's write down. It could be 6 and negative 4, or it could be negative 6 and 4. Now I'm going to check the math and see what adds, and I see, oh, that's the pair. If you want to write down a whole list that goes all the way down to here, that is absolutely fine. Do what feels comfortable to you. I'm just showing you how you can start to carry more of this work in your head, right? When the product is a minus, you know that the two factors are going to be plus and minus, and so this number will be the difference between them, right? Because you'll be adding one and subtracting the other. So that's how I quickly ruled it down to 6 and 4, because the difference between 6 and 4 is 2. And then I had to play with the pluses and minuses to get that to work, but it's plus 6 and minus 4. Yay! All right, so this ends the part of the lesson on talking about trinomials with common factors. Again, get them in order and then look at that first term and say, how do I turn that into an x squared? And that will help you figure out what to factor out. Once you figure that out and you factor it out, you just ignore that part of the problem, and this is all the same. Okay, yay, we're done with that. We have one more example, but I have to introduce a new topic to you. I get to introduce a new topic to you, and it'll make you feel smart. It's called subscripted variables. Here's the situation. When we're doing word problems, the whole challenge of word problems is to translate words into symbols, right? That's the tricky part. That's the part that everybody struggles with. Once we set up the equations, it's not a big deal. But everyone struggles with taking those words and turning them into symbols. Subscripted variables are a tool we can use that help in that process. And what we're doing is we're building more words from the story into our equations, right? We're just helping to bridge that gap. So what John's going to do now is not introduce us to the stories. He's going to get us used to just the weirdness of working with these subscripted variables. I'll show you what that means in a minute. It's just more letters that help us match our equation to the words in the story. I lied. I'm very sorry. There are 2 more problems, but that's okay. They'll be fun. Example 71.5. John says, use elimination to solve, and then he gives us a system of equations. But instead of cute little x's and y's, we have weird things. Here's the 5. And look at that, big N, little n. I'll tell you what that means in just a minute. And then here we have big N, little d. and then a plain number, thank heavens. Okay, if this was x, 5x plus 10y equals 125, and x plus y equals 16, it would be completely normal. The only thing we've done is we've used as subscripts, these little floaty letters down below, those are called subscripts written below. And what they do is they help us match, like I said, the equation to the words in the story. We're going to get two stories about the number of nickels and the number of dimes. That's what this stands for. We don't have the story yet, but I'm giving you spoilers. Number of nickels, number of dimes. In terms of the math, we treat it exactly as if it was just a regular x and y. There's nothing special about how they affect the math. It's just the way we talk ourselves through the equations to set them up. So we're going to ignore the fact that these have subscripts and solve this system of equations like we would ordinarily. And you'll see that there's no difference. We just are writing a little bit more. John asks us to use elimination to solve. So I vote, and I'm sorry, you're not here to vote with me or to overrule me. Let's multiply. No, I changed my mind. I want to multiply this. I want to eliminate here because I want to multiply by minus 10. It's easier to multiply 10 than it is to multiply by 5. 5's pretty easy, but 10's even easier. So I'm going to multiply this bottom equation by minus 10. And then I'm going to eliminate it against the top one. So here, let's multiply. Minus 10 n sub n, you can say, minus 10 n sub d equals minus 160. Okay, so I multiplied all this out. I wrote these just the same. I said them as n sub d. Later, when we have stories, we can say minus 10 times the number of nickels, minus 10 times the number of dimes equals minus 160. All right? So we can say them as the words to match the story, or we can just say n sub n. Now what I'm going to do is I'm going to squiggle this out because I don't need that line anymore. I might want to use it later, but right now my attention is turned to these two because they're the ones that I'm going to eliminate. So I do that light squiggle just to help me focus on the right parts. This and this, minus 5 times the number of nickels, oh look, number of dimes is gone, equals minus 35. Do you like it? Divide by minus 5. And we get n sub n, or the number of nickels, equals 7. Okay? There's no way of knowing in this problem that this means number of nickels. I'm just giving you spoilers. All right? That's what that's going to refer to. You can just say n sub n. Sub. All right? And then just like before, we're solving this. The math is exactly the same. We want to put this in, I'm going to put it into this one, the original, right? N sub n plus n sub d equals 16. So 7 plus n sub d equals 16, and we just subtract the 7 from both sides, and we get n sub d equals 9. Now, usually when we solve a system of equations, we say that we want to write our answer as an ordered pair, right? But because we are preparing for the stories, in the stories, we'll want to write it like this, right? Because we're finding the answer to how many nickels and how many dimes suit this story, right? So when we move into a story context, we don't need to write as ordered pairs. This form of the answer makes more sense. Okay, one more, and then we're done, I promise. 71.6. Use substitution to solve. Okay, so John's going to mix it up for us. And same thing, 5 times the number of nickels plus 25 times the number of, oh look, it's a Q, quarters. We're going to be doing some coin problems. Okay? And then number of quarters equals the number of nickels plus 2. All right? Subscripted variables, we're not going to sweat them. We just match them and know it's just like an X, it's just like a Y. We're going to substitute this time per John's instructions. Later you'll get to choose for yourself, but for now he's making sure that you practice both. And we can say, oh, we're all set up to substitute this and this match. So we'll take this expression and plug it in right there. So we'll have 5 times the number of nickels plus 25 times the quantity, number of nickels plus 2, equals 290. Okay? It's always a good idea to stop and check when you think you've got your system all set up. Make sure you used both equations. And we did. We put this into that. We're good. Later, we're going to be using 3 systems of equations. So I'm training you ahead of time to always do that. Stop and check and make sure you used all the pieces you're given. It's not so bad when there's just 2, but when it's 3, it's a little crazier. So practice that now. All right, let's distribute. This part is exactly the same. We just have to scribble more to get that variable written. But all the math works exactly the same. All right, there we are, all distributed. I'm going to combine these like terms. At the same time, I chase this plain number over to the other side of the fish. You're gone. 30 times the number of nickels equals 240. I think I'd like to divide that by 30. And I get the number of nickels equals 8, right? You can chop off the zeros. 3 goes into 24 8 times. All right, I feel good about it. Now we just need to plug this into one of our original equations to solve for the other variable. This is the gem, right? NQ, number of quarters. N sub Q is the better way to say that, equals 8, because 8 is the number of nickels, plus 2, so the number of quarters equals 10. Again, because this is the answer to a story problem, a word problem, we don't necessarily write it as an ordered pair. This is the more logical way to write it once we get the story. And we usually write it with the variables in the same order that they appear in the story. We haven't gotten that far yet, but this is how it will be. This is how they showed up. Well, only in one. Never mind. Write them in whatever order seems the most logical. There we are, 71.6. So these subscripted variables, don't let them stress you out. They make it look harder. Look how hard that looks. That looks really complicated. But substitution and elimination work exactly the same. You just look like a nutty professor. Okay, guess what? Lesson 71 is done. Good job. Thank you. Bye.